So I'm Claire. I'm a UX and product. The lines are fuzzy. People draw them in different places. So I call myself UX and product consultant. I do a lot of come from a software UX background. I'm a hardware person, but I had the opportunity a few years ago to start working on connected things, particularly connected home and consumer type stuff. So I'm really interested in the industrial stuff as well. But if I'm showing thermostats, it's not because that's all I can think of. It's because that is a world in which I've spent quite a lot of time. Since I spoke at ThingMonk a couple of years ago, I've managed to produce this, or most of this, in conjunction with some other people. And people have said nice things about it. Thank you, Andy, and others. So I've got a few of these to give away at the end, if you're interested. Connected things. I'm sure you are all well aware an IoT thing is not so much a thing as part of a system of distributed things. But when we talk about... sorry? Is my mic... Can you hear me?
Sorry, you need to just talk up. It's not fully mic'd. We're using the theatre as a thing.
Okay. Can you hear me okay? Not. Okay. Talk up. You mean like look up? Look up. Okay, let's assume there isn't. All right. So IoT products are essentially systems of more than one thing. They are distributed. I'm not technical, but they are. I understand that much. But when we talk about designing for them, we often talk about thinking essentially what's really only the nodes. So the bits that people actually experience. We talk about industrial design, things like Nest thermostat being an iconic example of that showed us that things can actually look nice. And the apps themselves. So often mobile apps don't have to be, but these are often the things we talk about with design. But what I'd like to say today is actually this is really what there are many things when you are building. I'm not an engineer, but there are many things that can go wrong. I'm informed if you architect a system. And just think about the bits and then kind of glue them together and don't think about the thing as a whole. There are lots of things that can happen in the gaps between those things that can cause problems. And the same thing happens with design. So we have to think not just about what the individual touch points are, the nodes if you like, but about how those things work together and about coherent experience across all of them. So I'm going to talk about some of the things the elements of that today. So the first thing is getting the user to understand how the system actually works. And the problem we have is that an IoT as a system may often be lots of devices that perhaps do slightly different things that work together in some way. The problem is that people are much better at thinking about things than they are at thinking about relationships between things. So if you think about the kind of the Why Things ecosystem, there are things that can measure body weight, there are cameras, there are things that measure blood pressure, but all of those things have some kind of relationship with one another. Now, this is all about conceptual models. This is about understanding how the thing itself works. And a conceptual model is a bridge between, first of all, users have to understand what your thing does in the first place and whether that's the thing that they want. They then have to understand approximately how it does that. It doesn't need to be detailed understanding, but some kind of understanding of which bit does what and how they work together in order to be able to figure out how to use it in the first place. Now, non-connected products are usually pretty simple. You think of something like a light. It has a bulb, it has a switch, and there is electricity. When you press the switch, the bulb lights up, and there we are. When you introduce connectivity into something like that, it gets a lot more complicated. So you may have there's a bulb that may be connected. It might talk to a bridge. That's another part in the whole ecosystem. To many people, a bridge or a hub is a bit of a kind of mysterious white box. It's not very obvious what it's doing. These are things that can be unplugged because somebody wants to use the Hoover, and then they don't understand why the lights have stopped working or the heating controllers stopped working. Then you've got the fluffy cloud and things happening in there, and then you've got some kind of control interface that may be on a smartphone. Now the issue with this is that now when all of that stuff is working, then really there's no problem. You don't really need to understand which bit does what, but inevitably sometimes some of those connections will break, or a part will stop working, or a bit of the network a network connection will go down. And what that then means is that users effectively have to understand something about the system model in order to understand which bit's not working, why things have gone wrong, and what to do about it. So if you have, for example, a connected lighting system, if you've got some automated rules and those rules are running in the cloud and your lights are not turning on at 8 o'clock in the evening as you expected them to, that might be because the internet connections between the cloud and the bulb is not working. If you have those rules running locally on a bridge, probably not on the bulb itself, but the lights will still work. So as a user, I have to have some understanding of what of the conditions that might cause my lights to stop working or not, and what to do, what will work, and if connectivity goes down. So there are a couple of ways of dealing with this, and the first one is that you can be very explicit and try and get the user to understand something about the system model. So the example on the left here, this is a Lowe's Iris American home automation system. Runs on a AlertMe platform. I used to work for AlertMe, which is why I've seen this. There's a little LED, kind of fake LED up in the top right here, which is essentially telling you that app at that point has a connection to the home gateway. So you can be reasonably confident if you want to change the temperature of your heating or cooling system at that point, that instruction will get through to the gateway. It's not making any guarantees that it will get through to the thermostat at that point, but you can get it through to the gateway. So things are working. Another example, this is the sadly defunct Berg's Cloud Bridge. This is being very explicit about whether the power's on, there's an Ethernet connection, we have an upstream connection to the cloud, we have a downstream connection to the edge devices. So if any of those things if anything goes wrong anywhere, you can see where the problem is and hopefully figure out what to do about it. The other thing you can do is pretend that none of this exists and is a problem, and basically simplify away the conceptual model so that the user can do what they need to do without necessarily having to understand all the nuts and bolts and all the things that are going on under the hood. And this is kind of how beacons work. So even in the reasonably technical press, it's quite common to hear beacon functionality described as the beacon is as if the beacon is actually sending you the notification. So if you walk into a store, you have a loyalty app, and it goes, hey, you can have a coffee, or hey, you can have a discount on a special offer. It's almost described as if that is coming from the beacon itself. Now that's not really what's happening, as I'm sure you're all aware. What's actually happening, the beacon's broadcasting a dumb thing, broadcasts a unique ID, phone detects the ID, wakes up the app that's associated with it. That app will check into the internet service and go, I have a thing for you, which gets pushed through to the phone. But you can use this perfectly well without knowing that that's what's happening. It doesn't matter as a user if you think that there is something in the store that's just going, and sending you that thing. And I think the right answer really depends on the kind of service that you're producing. People will obviously become more familiar with how things work, but I think if there is an opportunity to simplify it, that's a great thing to do. So related to that is the idea of figuring out which functionality you even need to put on which part of your system. There's a tale of two thermostats here. The one on the left is the Tardo. There's actually very little on the thermostat here. It's now got a temperature display. The first version of this was just a plain white plastic box. But most of the functionality has been offloaded onto the smartphone app, which is great in terms of keeping the cost of manufacturing the thermostat down. It means you can change the functionality, you can update the interface, the user-facing functionality, update the interface over time much more easily if you want to do that. But it does mean that if there's somebody in the home who hasn't got access to the smartphone app for whatever reason, or you can't find your phone, you are limited in what you can do with the system at that point. And then there's a bunch of others, like the ecobee, for example, where basically all of the functionality is mirrored across the device and on the smartphone app. So the downsides of that are if you want to change the functioning of the system over time, you've basically baked what it does into a hardware interface. But you will never be without control of the heating. And this is a really common pattern that we see, and it's something where there are decisions are made to go in different directions on very similar products. These are irrigation controllers, which we don't use much in the UK, but are a thing in home automation in the States. This one here is the Blue Spray. It's a kind of ugly plastic box that looks like it was designed to go in a bush. And all of the controls and all of the automation is handled via an Android app. This one here is the Skydrop, which was designed to look beautiful on your wall inside. You go, oh, the garden's looking a bit dry, and press a button. And all of that functionality is mirrored on a somewhat less beautiful iPhone app. So, you know, there are different decisions being made for different reasons between around the same kinds of products. I think it'd be interesting to see how some of those things standardise. The next thing is about consistency between interfaces. Now, this is all about consistency as a kind of old school usability principle, which was all around the Jakob Nielsen, the sort of one of the early pioneers certainly of usability, said, you know, users should not have to worry whether different words, situations, or actions mean the same thing. And he also said you must follow platform conventions. But the problem with designing for things that span different types of devices is that those two things may be in tension. So, you know, if you this is a slightly flippant example, but the hacker ball. This is a programmable ball for children made by Many and Map, which was supposed to be out for Christmas. I am following Kickstarter updates closely because I really want to have one of these at Christmas. But the idea here is that you know there's an iPad app and there's a ball, and you don't do the same kinds of things with an iPad that you do with a ball. Now, I'm pretty sure that they're not going to be designing something which invites you to drop the iPad or to throw it to people or bounce it. But you know, they're very different classes of device, and you can't do the same things with them. Now, the most important thing from my own work I found in terms of consistency is around terminology. However different the UIs across different devices, if you've got names for things on those UIs, you've got to make sure, and they are the same function, they must have the same name. Well, this doesn't always happen. This is the British Gas, the new British Gas Hive. They have it says manual. There's for manual and scheduled heating. This one is set to manual. This one is set to manual as well. There are other examples where the hardware will say auto. And the app will say schedule because they thought schedule was a nicer word. And this kind of stuff really confuses people. People already don't understand heating. If you're going to give the same function a different name on each thing, people are going to think it might be a different thing. So the other thing is platform conventions are really important. Don't try to make devices that are pretending to be other devices. There's some obvious visual similarities between the Nest iPhone app and the Nest thermostat. But you know they've been smart enough not to try to make a fake kind of bezel control, which is on the app, which is mirrors the hardware, and they haven't made a thermostat that's pretending to be an iPhone. So work with the properties of the devices that you have. Aside from the obvious visual similarities between the two, Nest also do something quite nice with audio to tie the thermostat and the phone app together. So if you rotate the bezel, you get a kind of subtle little clicking noise. If you adjust the temperature via the iPhone app by tapping up and down arrows, you get the same clicking noise. So it kind of makes it feel like it's all part of the same system. Excuse me. Where things really don't have to be the same is around things like interaction architecture. So the logical structure of the things that you want to do with that device might be very different depending on whether it's an app or whether it's a piece of hardware. Different features might be more or less important on different devices. If you've got a big screen, particularly a touch screen, you've got an opportunity to lay much more stuff out on that. If you've got a crappy old piece of hardware, this is a non-smart burglar alarm, but increasingly these things people are looking at retrofitting these things to be connected. Something like this has a really crap UI. It will have lots of modal controls. There'll be arcane kind of menu functions that you have to move around. You really don't want to be putting that stuff in a nice software interface. The next thing is about not just designing for the things themselves, but considering the connections between them and the network. And I think interesting things are going to happen when things in the real world start behaving like the internet. And I think we don't, we have a mental model that helps us understand latency and reliability issues. So we know that sometimes web pages will be slow to load, and Skype calls might fail. But we don't expect the physical world we don't expect these delays and these failures to occur in the physical world. If you turn your lights on, and they take 20 seconds to respond, there's going to be quite a lot of that at that period of time where you're going to think that actually this is just not working at all. So how do we handle this? You know, this cross-device interact. This is the another Berg example. This was if you haven't seen the CloudWash video from a couple of years ago, I would encourage you to watch it. It's a lovely piece of sort of part prototyping, I think, part design fiction. And it starts out with someone sort of setting a wash program on the phone, and you then see the washing machine display immediately, can show that, kick into that program and respond. Meanwhile, there's a voiceover saying, and this is happening over the internet. Yeah, okay. So obviously in the real world, if that really was happening over the internet, it might not be quite as smooth and immediate as that. So this has a knock-on effect for things that you might choose to do in the UI. So the way that we expect, the obvious, if you were designing a switch to turn on a lamp or a smart plug, the obvious design solution that would probably occur to you first is to have a switch that both, as you press it, it changes state, and that state change that you see is both confirming that you've pressed the switch and also that the light is on. But if there might be a delay between those things happening, or if in fact, that instruction might actually go missing, that can't be guaranteed necessarily. So if you do this, you press on and it's confirmed, the user can't actually tell whether that action has been executed or whether it's still in progress and it's just confirming that you've pressed the switch. So you have a couple of options for how you might handle this. And the first one is that, if you can, a lot of connected home technology takes this approach at the moment, just lie. Confirm the action, pretend you've done it, and then backpedal if something goes wrong. My hue lights work like this. You kind of crank up the brightness on the light, and it sort of goes yeah, and then it doesn't. And if it can't do it, the slider just sort of moves itself back down, and it's just kind of like, nah. All right. So I think that there's one. It would be lovely if it just said, I'm sorry, I couldn't do that, or just something. It's just like, no, I'm not going to do that. So here you say, all right, well, let's confirm that we're going to pretend that we've done this, and then if it actually happens, and the lamp actually turns on, then we're all good. If there's a problem, we'll tell you about it. This is very much like what Instagram do as well. So if you like a picture on Instagram, it's instantly shown as being liked, even though the instruction is technically actually being sent, and that hasn't been registered on the server yet. But you know what? It's just a photo. You're just liking a photo. It's not the end of the world if that doesn't happen right away. The second option is to be transparent, and this is to separate acknowledging the action from confirming that it was actually done. So confirm that the user's request and actually show the state change on the other device only when it's actually being done. So in this example, you might say, I press the on switch, I see something to tell me that instruction is being sent. Once you have confirmation as to whether or not it was successful, you either go, yeah, brilliant, your light's on, or sorry, there was a problem. And this is much more honest, but it does introduce the idea of failure into things which can feel a little bit kind of clunky over loss of interactions. Wemo do this really subtly. If you turn a switch off, or switch them on to off, you get this kind of interstitial state where the switch is an in-between colour and there's little animation, and then it confirms that it was switched to off or on. Lowe's Iris which I use as an example because it's very, very, very explicit about everything it's doing. This really does tell you this was designed by engineers, and you can tell. I like that about it, but sometimes it's a little bit much. So if you say change the temperature on your water heater, you might see a message that says sending changes, please don't exit, and then you kind of, I can't touch anything, it's going to break, and then when it's actually been changed, you get confirmation that that's been changed. It's less elegant. It introduces the idea of failure into everything, like turning the lights on and off and that kind of stuff, which kind of does feel a little bit like it's like have some more confidence, please. But in certain circumstances, that is actually what you need to do. The other thing is around intermittent connections, and as I'm sure you're all aware, lots of IoT devices are not constantly connected to the network. Users aren't really used to this. Users expect that because their phone is always connected or nearly always connected, and their computer's always connected, lack of connectivity on those devices is kind of, is a sort of an edge case. It's usually a sign that something is wrong. But a lot of devices, particularly those that need to conserve power, might only check into the network when they have intermittently for new instructions, or might only connect when they have data to send. And with the upshot of that in terms of user experience is that sometimes devices might be giving you conflicting information about the status of the system. So, for example, you might have a battery-powered heating controller that says, which only checks into the network every 90 seconds or every 2 minutes. You might be standing in front of that with a smartphone app and say, I want the temperature to be 21 and not 19. And there might be a gap of up to a minute and a half where the two devices are basically telling you that the system is doing something different. So you have to figure out how to handle that. You have to say, well, perhaps indicate, when this thing last checked into the network, and it potentially explain that delay. And the way you choose to do this really kind of depends on how acceptable it is to have some uncertainty in the some uncertainty about what the system's actually doing. For certain things like energy monitoring, it doesn't really matter if you don't necessarily have the latest data. It's not critical. For other things like an elderly person's emergency alarm, it's really, really important that, for example, you don't give the impression that help is on the way if someone has summoned help unless it actually is. So you might want to take that really explicit approach and say, we are currently calling for help, and not the approach of saying, we've called help and then we'll tell you if there's a problem, perhaps later down the line. And this comes down to, also the value of data for people and the timeliness of data and the precision. Sometimes really precise data is fine, even if it's a little bit old. For example, body weight. If you know what your weight was 3 days ago, that's pretty useful. That's probably still quite a useful piece of information. It probably hasn't changed that much. If you know what your blood sugar was 3 days ago, that probably isn't very useful. So one example of that might be to show some of that uncertainty to the user. Sometimes, so you might say, if you've got a cat that's gone missing with a pet tracker, I'm desperately trying to find one of these that's actually a practical size for a cat to wear. There are many that claim that they are and they're not. If anyone knows of any of those, I'd be happy to hear about it. So you might say, well, actually, the last reading we had from your cat was 20 minutes ago, and they were here. Well, that's okay, but cats can go quite fast if they want to, if they've been frightened by something. So maybe it's more useful in that situation to sort of show that uncertainty and say, well, we think the cat's maybe somewhere around about here. Perhaps from previous readings, we think their direction of travel might be in a particular direction. And the final thing is that physical controls often represent state, physical controls of unconnected things. But when they can also be controlled by remote UI, you have to figure out ways of reflecting those changes. Hello? Okay. So dials are very common on things. Dials like these are kitchen appliance dials. They are used. You use them to both select what you want, but also you can glance at them and see what the appliance is actually doing. If you have a remote interface to those things, and you can also select those functions from, for example, a phone app, how does that physical interface change to reflect what you've done? If you change a wash program from a smartphone app, you can't necessarily have a physical dial that will tell you exactly, that will, unless you motorize it. If you switch to a different program, what happens? Do you move the dial? And so if you look at dimmer switches in lighting, you see that the kinds of designs that appear for connected ones are different from the kinds of designs that have become conventional for unconnected ones. So a conventional dimmer switch is a sort of unmarked dial which you can rotate. There's a maximum and a minimum setting. But if you were controlling, if you also had a remote interface to that, and you sort of turn the lights up to maximum, while the physical dimmer is set to minimum, where do you go from that? There's no way. You can't then use the physical switch to turn the lights down again because it's already on the minimum setting. So you need some kind of different approach to that. This is a Lutron connected dimmer. You can see that you can turn the light on and off. You also have these up and down arrows, which allow you to kind of increase the brightness or reduce the brightness. And there's a little row of LEDs, which shows you the setting that system's currently, the setting that it's currently on, so the brightness setting it's currently on. So this is a completely different way of controlling lighting, but it's one that can be used to convey the information that from the state that's being changed from the phone app. So you can see, you know, there's no maximum and minimum, and it allows you to show those changes. So in summary, some of these issues are helping people understand how the system works as a whole, figuring out whether you can simplify that conceptual model, which they need in order to be able to figure out how to interact with the thing, figuring out how to distribute functionality between the different UIs to suit what it is people are trying to do, figuring out what appropriate consistency between those UIs looks like, thinking about what happens, the experience of using the network, as well as the experience of using the nodes themselves and what that means that you need to put in the UI, and figuring out how physical UIs might need to evolve when you've put connectivity into them. So this is a summary of some of the things we talk about in the book. If you would like one, I have 3 to give away. In fact, you could, if you are tweeting, you can tweet ThingMonk and say that you would like one, and I will give them to the first 3 people to respond. If you don't manage to get one of those, there is a code, AuthD, which you can use on the O'Reilly shop to get 50% off the ebook and 40% off print, or I have some cards to give away, which will do the same thing. Thank you.